So welcome back to Backer Breaks It Down. In this episode, we will officially solve right triangles. So in the previous episode, I simply focused on finding like one missing side or one missing angle, but like if you can find one, you can find them all. And so the process of solving a right triangle means you're finding all missing measurements. Now, there are a few ways that you can do this depending on what you've been given. Like, you can use the Pythagorean theorem to find a missing side if two sides are known. You can use complementary angles to find a missing angle if two angles are known. And by the two angles, I mean like you know the right angle and you know one of the two acute angles. So it makes sense when they say complementary because like in any triangle, like all three angles add up to be 180. Well, in a right triangle, one of the angles is 90 degrees. So that means like the other two angles have to add to be 90 as well, right? And when two angles add to be 90, that's what complementary angles are. So if you know one acute angle, you can simply subtract from 90 to find the other one. And then, of course, you can use sine, cosine, and tangent to find missing sides and missing angles, right? You just start by like assessing the situation, like what would be the easiest thing to find that first. So like in number 5 here, we're given that angle B is 23 degrees, and we're given the side adjacent to angle B. And so like the easiest thing to find right away would be like the measure of angle A, because I can simply go like 90 minus 23. Well, that's 57. So that's what angle A is. When it comes to the other two sides, I'm thinking we use trig. Since we know the adjacent side, that means we're not going to use sine in this problem because sine doesn't use the adjacent side at all. But to find side AC, AC is opposite the given angle, so I can use tangent. And AB is the hypotenuse to the given angle, so I can use cosine. All right, so let's check out what I did, right? So I found side AC. Okay, so I've indicated AC is by the letter B because it's opposite angle B. Okay, so I wrote tangent of 23 degrees is equal to B over 14. From there, I cross multiplied. So I went 14 times tangent of 23. That's what I'm showing here. And of course, that's perfect. I can totally calculate that. So I got 5.94. To find side C, which is the hypotenuse, I used cosine. So I say cosine of 23 is equal to 14 over C, because cosine's the adjacent over the hypotenuse. I did my cross multiplying, and then I realized I had to divide as well. So ultimately, C is 14 divided by cosine of 23, which is 15.21. So this is like one scenario that you could encounter where you're given one of the acute angles and one of the sides. The other scenario could be you're given two sides. Okay, so when I look at this, I immediately am taken back to probably junior high. When I learned Pythagorean theorem, it's like, oh, the leg squared plus the other leg squared is the hypotenuse squared. That's what Pythagorean theorem technically says, right? Most of us know Pythagorean theorem, however, by, let me finish writing that, by like a squared plus b squared is c squared. Oh my goodness. Sorry, it's getting really messy. But a and b are the legs and c is the hypotenuse. So we can totally use Pythagorean theorem to find side AB. When it comes to my angles, like if I want to go alphabetical and find angle A first, I have to be like, well, what do I know? And it's like, well, I know the opposite and I know the adjacent. So that means I can use an inverse tangent function to find my angle A. So let's see what I did. So I started off by using the Pythagorean theorem to find side AB, and I got that it was 9.09. I used an inverse tangent to find the measure of angle A, since like I knew the opposite, right? So I said the measure of angle A is equal to the inverse tangent of 5.8 divided by 7, because tangent is opposite over adjacent. And I got that angle A was 39.6. I'm also showing that I used an inverse tangent ratio for angle B. Notice the ratio's been like flipped because the opposite changed. Another thing I could have done besides like another trig ratio to find the measure of angle B is I simply could have gone like 90 minus 39.6. And that would have given me 50.4 as well. Right. So this is how we can use our Pythagorean theorem in our right triangle trig relationships to solve right triangles, which is basically find all missing measurements. And that's how Becker breaks it down.